Hello friends, welcome to our lectures today. On our lectures today, we're going to be studying equations involving indices. Now, according to the laws of indices, if we are given b raised to power x equal to b raised to power y. Now, according to the laws, we can cancel out the bases since they are the same, right? And then equate the powers. Since the bases are the same, the bases cancel out, and there we have it that x will be equal to y. Now, we could be giving questions to the extent of 27 raised to power x plus 1, 27 raised to power x plus 1 equal to 1 over 9x. How do we evaluate this whole piece? Now, we know that 27 in index form would be 3 raised to power 3, because 27 is 3 times 3 times 3. So this gives us 27 as 3 raised to power 3, right? Raised to power 3. Now, let's not forget our x plus 1. We enclose that in a bracket. X plus 1 in a bracket. Now, on this other side, we have 1 over, now 9 now in index form will be 3 raised to power 2. Why is that? Because 3 times 3 gives us 9, so that gives us 3 raised to power 2. And let's not forget our x now. We don't need to include this in the bracket because it's just one value. Now, moving on, we can choose now to open up this bracket. And this gives us 3 raised to power 3 times x here gives us 3x. Now, 3 times positive 1 gives us positive 3. Now, on this other side, remember, right, our negative index law, which states that 1a now raised to power minus x, a raised to power minus s. We can choose to write this as 1 over a raised to power x. This was our negative index law. So I'm going to reverse the process in this form now. I'm going to reverse the process here and convert it back to this form, a raised to power x form. Let me take that off. Now, we have 3 raised to power minus 2x in order to make these bases equal. Now, we notice now that as we have done now, the bases are now equal, right? So this base cancels out and this base cancels out because they are equal. So we now equate the powers. So this gives us 3x plus 3. So in the aftermath, on this other side, we have equal to minus 2x. That is what we have. So what we do now, we collect like terms, right? So we move this negative 2x over here and move this positive 3 over here. So this gives us 3x plus, this negative 2x moving over here becomes positive. So plus 2x. 3x plus 2x. Now, this positive 3 now, moving over here becomes negative 3. So equal to minus 3. Now, this gives us 3x plus 2x gives us 5x. Now, on this side, we are left with what? Minus 3. So in order to find our x now, we divide both sides by 5. And in the end, our x is equal to negative 3 over 5. That would be the value of our x. So that's how we can evaluate indices involving equations, right? So let's take one more example and see how it goes. here we have another equation presented before us, and this is a form of a simultaneous equation. So we'll have to evaluate these simultaneously. We are told to find x and y. X and y. So in finding x and y, I can choose to write 7x plus 2y, right? I can choose to rewrite this first equation, our 7x plus 2y, equal to 7 raised to power 1. So here we notice that a number standing on its own has an imaginary power of 1. An imaginary power of 1. So here, since the bases are equal, this base cancels out and this base what cancels out. So we are left with x plus 2y equal to 1 as our first equation. We can name that equation 1. Equation 1. Now, for the second equation now, we have 9x raised to power x now plus 3y, 9 raised to power x plus 3y equal to, notice that 81 is the square of 9, right? So 9 square gives us 81. So we have 9 raised to power 2. That is 9 square. Now notice that the bases are similar, right? So this base cancels out this base. And for our second equation, we are left with what? X plus 3y equal to what? 2. That would be our second equation. Now, we can evaluate this simultaneously by using the elimination method, right? So using the elimination method, we can subtract these two equations, right, to find one of our variables. So x minus s cancels out. Now, it cancels out, so that's 0, right? Now, on this side now, we have 2y minus 3y. 2y minus 3y. So that gives us minus y. Here also we have 1 minus 2. 1 minus 2. And what we have there is minus 1. So this negative sign cancels this negative sign. And in the end, y is equal to 1. Y is equal to 1. So now we can put the value of y into equation 1, right? So this would be equation 1, x plus 2y. So instead of writing y, since I know that my y is 1, I can put 1 here, and this will be equal to 1. I'm just substituting the value of y into this very equation 1, this equation 1 right here. So in opening that bracket, we have x plus 2 times 1 still gives us the very same 2. So we are going to write 2 equal to 1. So we're going to collect like terms. Now we're going to be moving this 2 over here. We're going to be moving that 2 over there. And what we are going to be having would be x equal to 1. This is a positive 2 now. Moving it over here makes it a negative 2. 1 minus 2. 1 minus 2. So in the end, x would be equal to minus 1. And your y would be equal to what? 1. There you have it, guys. That's how we can evaluate problems in indices involving equations, right? That's how we can do that. Thank you so very much for watching. See you in the next video.